We're looking at the graphs of exponential and logarithmic functions. So exponential functions, exponential graphs, you should have already seen this in eMath. If I'm not wrong, this is chapter 5 of Sec 3 eMath. Okay. So considering the equation y equals to a to the power of x. If a is greater than 1, then your graph will look like this on the left-hand side here. Right? This is if a is greater than 1. If a is between 1 and 0, then the graph will actually look like this. Okay? Now, a cannot be negative, okay? Because if a is negative, let's say a is minus 5, then this function, this wouldn't be a function. Because if let's say x is half, then y will become negative 5 raised to the power of half. So y equals to square root minus 5, which cannot happen because you cannot take the square root of a negative number. You won't get a real result. Right? So that's why a must be greater than 0. Now take note that both graphs have asymptote y is 0. So both graphs have asymptote here. Okay, y is 0. They tend to it and it looks like they touch, but they don't. They don't touch. They just approach. Okay. So now what if we say that a is strictly greater than 0? So this should be greater than 1. A is greater than 1. My bad. If a is greater than 1, then y equals a to the power x will look like this. Okay, look like this. Right? And then y equals a to the power minus x will look like this instead. Okay? And take note, both graphs still have asymptote at y equals to 0. Okay? So, how do we find the intersection of the graph with the y-axis? So, because the graph has an asymptote at y equal to 0, there is no intersection with the x-axis. So there's only an intersection with the y-axis. So to find the intersection with the y-axis, we need to let x equal to 0. So I let x equal to 0, and I get y equals to e to the power of 0. And that's considering the equation is y equals e to the power of x. It's a very common exponential equation. So then e to the power of 0 is 1 because anything raised to the power of 0 is 1. So the graph intersects the y-axis at 1, 0. Okay. So let's say I have an exponential equation in the form of y equals to a multiplied by a to the power x plus b. Now, a is actually called your pre-exponential multiplier, and b is your vertical shift. Now, a characteristic of exponential graphs is actually the intersection with the y-axis. So when we want to draw exponential graphs, we should always find that intersection first. So the way to do it is always very standard. We let x equal to 0. So I let x equal to 0, I get a multiplied by a to the power of 0 plus b, which is a plus b, because a to the power of 0 is 1. So a plus b. So the intersection of the y-axis is at 0, a plus b. Okay? How about the asymptote? For y equals e to the power of x, the asymptote was at y equals to 0. But for a graph that has been shifted upwards by this vertical shift, my asymptote will now be y equals to b. Let's take a look at the equation. So let's consider this equation. Y equals 3 times e to the power x plus 2. To find the y-intercept again, we let x is 0, then we get that the intersection is at 0, 5. And then the asymptote is actually just your vertical shift. So it's y equals to 2 in this case. Now, if your vertical shift were negative, then it will shift the entire graph down. So there would be a chance where your graph actually intersects the x-axis, but your intersection won't be a very nice number. It'll be some random decimal. And there's not really a point of solving for it. So we usually don't label it unless the question asks for it. Now, how about the shape of logarithmic graphs? So y equals to log x base a, where a is greater than 1, will have a shape like this, okay? And take note, this graph has the asymptote at x equals to 0. So x equal to 0 will be here. Okay, yeah. Instead of having an intersection with the y-axis, this graph will intersect the x-axis instead. So to solve for the intersection of the x-axis, we let y equals to 0. So when we let y equals to 0, we get that 0 equals to ln x. And let's solve for x. So x equals to e to the power of 0 by rewriting a logarithm into exponential form. Yeah, that's how I get this x equals to e to the power of 0, which is 1. So the intersection with the x-axis is at 1, 0. Okay. So logarithmic functions in the form of log x base a multiplied by a will have x-intercept here and asymptote x equal to 0. So log of y equals to 3 ln x. So to find the x-intercept, it's standard, right? It is 1, 0. It is always 1, 0. And the asymptote is x equals to 0, which is this line. And take note, you need to label the equation of your asymptote. So here is your intersection at 1, 0. X is 1, y is 0. Okay.
Smash your maths exams. Download Learn Maths Today for real exam questions and achieve top marks.